you all for attending today's educational webinar on electronic leak detection and TruGround Conductive Primer. My name is Chris Kahn. I'm the product manager for the roof garden and paver systems, as well as the Detec TruGround Conductive Primer, which we'll be talking about here during this presentation. So what we're going to be trying to address here during the presentation is common questions that we get and that we regularly receive about ELD testing, as well as the conductive substrates that are needed for conventional roofing assemblies. We're going to explain what ELD testing is, how it works, the 4 ASTM recognized ELD testing methods, as well as conductive substrates. We'll finish off the presentation by explaining Detec TruGround Conductive Primer, which I believe many of you should know that Carlisle began selling and stocking earlier this year. The presentation is going to be a collaborative effort between myself and Sean Katz of Detec Systems. Sean is Detec's sales manager and has been employed at Detec for 6 years. Before I turn it over to Sean, I want to mention that if you have any questions, please submit them through the GoToWebinar user interface little questions tab. We will get to as many questions as we can towards the end. We should have plenty of time to address all questions. But if by chance we don't get to all of them, I'll make sure that I send a follow-up email addressing all the questions that came in. And so with that, I'm going to turn it over to Sean to get us started, and I'll check back in towards the end when we're talking specifically about Carlisle's TruGround product that we offer.
Thanks, Chris. Again, everybody, my name is Sean Katz. I am the sales manager, the product line manager for Detec Systems. We are a small electrical engineering firm that has invented leak detection testing and monitoring technologies. And today's presentation is entitled An Introduction to Electronic Leak Detection Testing and the TruGround Conductive Primer. This presentation will cover the physics of ELD, as well as the 4 different testing methods that are found in the ASTM standards. I'll also talk about valid leak detection assemblies and which ones need what's called a conductive medium. That's something that gets added into a roof assembly to make ELD work when needed, and usually that is in conventional roofing. Then I'll talk. Then we'll open it up to questions. And again, if you have any questions, send them in through the chat. We will address those at the end of the presentation. Electronic leak detection is a generic term that is used for the 4 different methods that pinpoint breaches, holes, and seam voids in roofing and waterproofing membranes. Typically, all 4 methods are used in new construction as a quality control test. They pinpoint the breaches, holes, and seam voids in those membranes. And they all do that by applying an electrical current to the surface of the membrane, and at the location of a breach that electrical current can flow through, it touches a conductive substrate under the membrane, which then carries the electrical current back to where the equipment was connected to that substrate. So what you're seeing here is a typical waterproofing assembly with the membrane installed directly onto structural concrete. Structural concrete is already sufficiently conductive. This is where the equipment would be connected to building ground. Usually that would be a metallic penetration, such as a metal drain bowl or lightning rod or anchor, exposed rebar. The equipment applies the voltage to the surface of the membrane. That current flows through the membrane to that concrete, and the concrete's able to carry the current back to the metallic penetration. So that is the physics of ELD on a typical waterproofing assembly. Now, on a conventional roof, there's usually coverboard, insulation, and a vapor barrier below that membrane. And none of those layers can carry an electrical charge, meaning ELD will not work. In new construction, if the membrane's already installed, these layers are blocking that electrical path to the concrete or metal deck. So in new construction of a conventional roof, there has to be an added conductive medium to make ELD possible. And that would be the TruGround Conductive Primer. That's what you're seeing here in this image, is the TruGround is added to the substrate directly under the membrane. In this case, it's coverboard, and that provides that required conductivity. So now ELD is possible. These breaches can be found, repaired, and retested before the warranty begins or before that customer moves into that building. So that is the physics of ELD on a new conventional roof. These are the two ASTM standards for ELD. The first was published in 2014, and that is the ASTM Standard Guide D7877. And that lists the 4 different ELD methods, which are Detec scanning platform. There's also Detec's vertical roller, and then there's what's called low voltage vector mapping, and then there's high voltage, which is also known as spark testing or holiday testing. And so that guideline, that 7877, lists those 4 methods. It describes the testing apparatus that's used, the testing procedure, and the limitations of that test. Other than that, all 4 methods have the same physics and same basic requirements. They all find breaches the exact same way: conductive substrate, exposed membrane, electrical path from the top down, same exact physics. Now, after 2014, the ASTM committee requested that each method create their own standard practice. Well, the only 2 methods that proceeded with doing that were the scanning platform and the vertical roller. They usually come together, and those are Detec's equipment. And so the only standard practice for ELD is the D8231 that came out in 2019. It's expanding on that 7877, but it is specific to just Detec's scanning platform and vertical roller. And the D8231 also reflects all the technical advancements in ELD after 2014. And so, for example, in 2014, black EPDM could not be ELD tested because it's semiconductive. It contains carbon black. And so that was the case for all 4 ELD methods. And then in 2017, the scanning platform was modified to be able to start testing semiconductive membranes, such as black EPDM. And so that technical advancement, that new ability in ELD is reflected in that D8231. And the D8231 also mandates that ELD testing must be done prior to the placement of overburden. You can't test through overburden with reliable, repeatable results. I'll get to that here shortly. So these are the 4 basic requirements for all 4 ELD methods. They all have to have a conductive substrate directly under the membrane. And on the waterproofing side, that's usually concrete. And on the roofing side, it's got to be a conductive medium, such as TruGround conductive primer. And they all have to have a ground connection to that substrate, something that is metallic or conductive that is connected to that substrate and penetrating the membrane. Usually that would be a metallic drain bowl, lightning rods, anchors, HVAC units, exposed rebar, anything that you can connect your cable to that is metallic and it's touching that substrate. They all have to have an exposed membrane, meaning it cannot be covered by overburden. There is no way to reliably get an electrical current through overburden with reliable, repeatable results. I will talk about that here shortly. And they all have to have an electrical path from the surface of that membrane to the surface of the conductive substrate. So low voltage methods use water. And water is what carries the electrical current. Wherever that current or wherever the water flows, the electricity flows. And then there's high voltage, which does not use water, and it's a direct vertical air gap, and you can actually see the spark travel through air. So this is high voltage, there's the spark. High voltage was created for testing coatings on pipes, and then that technology was adapted for the roofing and the waterproofing industry. It works on horizontals, verticals, transitions, but it does not work on semiconductive membranes such as black EPDM. The technician applies up to 40,000 volts to the surface of a completely dry membrane. And at the location of a breach, there'll be a spark, and they can hear a pop, and the electronics will beep. The limitations of this method is that it can only be done in dry conditions. And so rarely is this ever seen here in the Pacific Northwest. It cannot be performed in inclement weather. There cannot be pooled water or frost or dew or trapped water under a protection course, all of that can create a false positive. They'll spark into that moisture thinking it's a breach. So the membrane surface does have to be completely dry. And the technician has to adjust their voltage for the mill thickness that they're testing. And so in a fluid applied situation, if that thickness fluctuates and the voltage is set too high, it can actually burn through the membrane. And if the voltage is set too low, it won't even spark at all. So it's heavily reliant on that technician to have the proper sensitivity, the voltage set. And this method is not the best for seam void detection, and that's because the spark only travels vertically through a direct vertical air gap. It does not travel horizontally. And so seam void detection is better with low voltage methods because wherever the water can flow, the electrical current can flow. High voltage does not work on semiconductive membranes such as black EPDM, and it is not suggested for those with a pacemaker or to be used in combustible areas. The first low voltage method I'll tell you about is called vector mapping. Sometimes it's called EFVM or vector testing. There's a lot of different terms that are used for it. This was also created in Europe in the 1970s. And this was originally created for testing pond liners that were filled with water. And then the technology was adapted for the roofing and the waterproofing industry. How this works is this works on horizontal surfaces that are non-conductive. So this does not work on black EPDM. The technician sets up a wire along the perimeter of a testing area. There it is in the background. And all that wire does is it isolates the area, usually up to 7,000 square feet or so. And then within that wire, they have to isolate every single grounded object, such as a drain. And that's because those will be seen as a breach or a hole in that membrane. And then the membrane has to be flooded with water. The perimeter wire is pulsed with up to 40 volts of electricity. And that electricity requires water to flow within that isolation area. So the larger the area that's isolated, the more water that's needed to carry that electrical current. So if there's drains or the area is sloped or there's dry spots or there's gaps in that water coverage, all of that can result in a break in the electrical path, in that water path. So that's why best practice is with this method that they flood it with at least a 1/4 inch of water or more. Some testing agencies will use dish soap to help create that continuous film. Again, the larger the area that's isolated, the more water that's needed, and dish soap will help create that continuous film, but it's also an OSHA nightmare. Now with vector mapping, they set up the wire along the perimeter, they isolate the grounded objects, they flood the membrane, and then they use these probes, and the electronics point in the direction of a drop in voltage. And so what that means is the perimeter wire is pulsed with 40 volts. The surface of the membrane is 40 volts. That's where the water is. And then the location of a breach or the hole is 0 volts. That's building ground. And so the electronics sees the sum of the entire area, pointing in the direction of everywhere where there's a drop in voltage. So if there's a lot of breaches, that test can take forever. So basically they just kind of hunt and peck and poke and prod, pointing in the direction of a drop in voltage. When they find a breach, it has to be isolated or repaired right then and there. Otherwise, the equipment will continue to sense it or point in that direction throughout that test. And that can make testing very, very difficult if there's a lot of breaches. Also, because it's pointing in that direction of a drop in voltage, you could have 2 breaches close in proximity, but it's pointing in that same direction. So multiple breaches in a specific area that it's pointing to might get missed. Most companies that use vector mapping will never, ever use it on a vertical surface. It can be done. It's just not really feasible. The technician would have to set up a wire on a vertical wall, like a window frame or a picture frame. Usually one extra body will have to stand there spraying water. The water has to hit that perimeter wire which is charging the water with 40 volts, and the water needs to flow in a continuous path to that breach, through that breach, and to the conductive substrate below. So it can be done. It's just not really reliable. It's not feasible. Most technicians or companies that use the vector mapping equipment will use high voltage or the vertical roller for a vertical surface. Now, because this method has to isolate the area, usually that wire is 4 to 6 inches from the wall, meaning the transitions cannot be tested using this method. And because they have to isolate every grounded object, those cannot be tested around. And these are some of the most common areas where breaches actually are found in a membrane. You all might hear that this method can work through overburden, and it can in very limited situations, such as gravel installed directly on the surface of a membrane, because in that case, the tips of these probes can physically contact that membrane, but it still requires that wire to be left in place below the gravel and the membrane to be completely flooded. And so within those limitations, it might be able to find something. Now, if that membrane is covered by electrically insulating materials, such as drain mat, root barrier, or insulation, none of those layers can carry an electrical charge. And the only way that they can is if they're saturated with water, which means the more insulating layers added above the membrane, the more water that's needed from the top down to complete that circuit. So in an extensive overburden situation, here's the only way it would possibly even work. The substrate directly under the membrane would have to be concrete. The membrane would have to be non-conductive. The wire would have to be left in place on the surface of the membrane. Now keep in mind that method probably did not test verticals, could not test transitions, and could not test around grounded objects. So there could be breaches present in the membrane that weren't even found in that initial test. And after that test is performed, other trades will come in. They might move or disconnect or trip over that wire or damage that cable. There's no way for a technician to know in the future when they're standing on the surface of the overburden the condition of the left in place wire. And that entire test is dependent on that wire to be left exactly where it was in the condition that it was left in. And the membrane has to be flooded with water. Again, the water is what's carrying the electrical current. There is no way for a technician to know how much water is physically standing on the surface of the membrane. That whole test is dependent on that. And then there has to be that continuous unbroken water path from the surface of the overburden through all these layers and coming in contact with a completely flooded membrane. And this water path from the top of the overburden to that membrane cannot be confirmed. So this might be used as a troubleshooting feature, but a left in place wire should never be part of the specifications. That gives that false pretense to the roofers, the manufacturers, the building owner, consultants, architects, that there's this magic ability to just show up in the future, stand on the surface of the overburden, it's just going to pinpoint breaches. That is not correct. That is complete bogus. It is not a claim that is supported by vector mapping equipment manufacturers. And again, if it was able to find something in this type of assembly within all of those limitations, the overburden would have to be removed, membrane exposed, and test repeated. So valid ELD is only on an exposed membrane. Same thing for split slab. This topping slab is often electrically grounded, meaning the moment the probes hit this surface, it's grounded out. Even if it could test through this, it would need the water from the surface of that overburden through all these layers coming in contact with a flooded membrane, which will never ever happen. So again, valid ELD is only on that exposed membrane prior to the placement of overburden. I see it in specifications all the time to leave a wire in place under pavers on pedestals. Low voltage ELD doesn't jump through air, it flows through water. So if these pavers on pedestals remain in place, it's got to be flooded from the top down, which I think we all know will most likely never, ever, ever happen. So again, valid ELD is only on that exposed membrane prior to placement of overburden. So with this method, these are the limitations. It's the only one with a lengthy setup process. It's the only one that has to isolate the testing area, isolate the grounded objects, and because of that, it cannot test transitions. It cannot test around those grounded objects. It also requires a lot of water. The larger the area that's isolated, the more water that's needed. And if not enough water is used, and there's a gap in that water coverage, breaches will absolutely get missed. Testing verticals is not feasible with this method. It can be done, it's just not easily done. Most vector mapping companies will never even make that claim. And this does not work on semiconductive membranes such as black EPDM. Now, in the early 2000s, 2 new additional ELD methods were created. And
Hey,
that
Sean,
is
I just want to add one thing before you start into the Detec stuff. One of the things that I get questions on a lot, or anytime somebody emails me about electronic leak detection, they seem to kind of use it interchangeably with EFVM. And I think you made it really clear, but I just want to highlight that fact. EFVM is a method of ELD testing. So
electric field vector mapping is what it's called.
So I would just suggest to everyone on the call that, if you are working with an architect or talking about a project, get in the habit of calling electronic leak detection and not EFVM or vector mapping.
That's right.
Because that's all you're doing is limiting what system or what testing system can be used. So we want to get out of that habit of calling ELD EFVM. I just wanted to be clear about that, but back to you, Sean.
Absolutely correct. I can't tell you how many times people call and they say, we need a vector test. And I have to explain, we don't do vector testing. We perform ELD. Same physics, different method. So that's why the current term everybody needs to use is ELD. That is the term that encompasses all 4 methods from the 7877. So if you call for EFVM, that is specific to one method and those limitations. If you call for ELD, then that could mean any of these 4. So thank you, Chris. I do appreciate you chiming in with that. So the final methods I'll tell you about, they're called the low voltage scanning platform and the low voltage vertical roller, or the scanning unit. Now, these units were specifically created to simplify ELD. It had been 30 years after vector mapping and high voltage had been created. The patents ran out. Multiple companies are making the equipment, but the technology remained the same as it always had. Same limitations, same procedure, very, very technical in use. And so these methods were created to simplify ELD, to make it more user-friendly, to take out some of that guesswork, and kind of be the best of both worlds. And so these methods have that speed and ease of high voltage where they don't need to set up the wire, and they have the ability to test the horizontals and verticals like high voltage. But it's got the reliability of low voltage because wherever the water can flow, the electrical current will flow. And so again, these units took the best of high voltage and low voltage and made a new low voltage method that was more capable than what was previously around. And so the scanning platform is designed for testing horizontal surfaces only, but this is capable of testing both non-conductive and semiconductive membranes. And so this is the only unit out of the 4 that can test nearly every single type of membrane out there, including black EPDM. There's also some cold fluid coatings that contain carbon black. And then there's cold fluid coatings that have a high moisture content. That also makes them conductive. So this is the only unit that can test those types of membranes. Similar to vector mapping, they would set up the wire to isolate the area. This unit has it built in. It's the exact same type of physics. And this outer chain is just isolating the area to about 24 by 10 inches at all times. That's your testing area. And then the center chain is pulsed with 9 volts of electricity. And that electricity is contained within this outer chain. So the equipment won't even sense that breach or go into full alarm until it's directly below the platform. There's also a built-in feature to where the technician can place their hand on what's called a secondary sensor bolt. And basically all that does is that's passing 9 volts through the human body, out their hand. The body is conductive. And so the human body becomes an extension of this equipment. So that's how testing is done around very difficult to reach areas or tight spaces, or around the flashings around a grounded object. And that's also how we are able to test around drains. So if you're looking at this image here on the right, vector mapping would isolate that drain. High voltage would spark as soon as there's a direct vertical air gap. This unit, the human body, can carry the electrical current so the fingers can test right up to around that grounded object. The final method I'll tell you about is called the vertical roller. Same physics. The difference is this doesn't have that isolation area built into it. So it's just like that center chain in the platform, which is the leak locating sensor. It's always searching for breaches. This works on horizontals, verticals, transitions, details, but it does not work on a conductive membrane like black EPDM. Now, with that being said, we have invented the ability to test vertical conductive membranes, and that technology will be released next year. So it'll basically just be another attachment for this equipment that enables the ability to test those vertical conductive membranes. How it works is the technician saturates this roller in a bucket of water. The electronics are electrically charging this metallic frame, which is connected to that roller. It's pressed against the membrane and dragged up that vertical surface, pushing the water into the membrane. And at the exact location of a breach, the electronics will alarm. So again, these two units were specifically created for ELD compared to the other ones, and they were created to make ELD more user-friendly, to take out some of the guessing work, to speed up the setup process for low voltage and create the ability to reliably test verticals. So it was created to make ELD more capable with a low voltage method. So really the limitations of the platform is that it only works on a horizontal surface, and that surface does need to be wet, not flooded, but wet. Physics of ELD needs a water path from the top down, and the roller has to be saturated with water. Wherever that roller goes, the electrical current will flow. And the roller cannot test semiconductive membranes such as black EPDM. Again, we have invented the ability. That unit is in design, the prototype phase right now, and will be released next year. So here is a comparison of all 4 ELD methods. They can all test an inverted assembly, which is usually a membrane directly onto concrete. They can all test a new conventional roof with an added conductive medium, like our TruGround. Only high voltage works in dry conditions, and low voltage methods work in wet conditions. They can all pinpoint a breach in a membrane. Vector mapping takes longer, but they can all find those voids. Now, when it comes to testing 100% of the area, vector mapping fails in that category because it cannot test transitions or around grounded objects. It's also the slowest out of the 4 because it's the only one with a setup process. It has to isolate the testing area, isolate every grounded object, flood the membrane, and then the more breaches present, the longer that test takes. Only high voltage and the roller can reliably test a vertical surface, and seam void detection is best for low voltage methods because, again, wherever the water can flow, the electrical current will flow. And currently, only the scanning platform can test both non-conductive and semiconductive membranes, including black EPDM, and a new vertical unit will be available next year. So typically all 4 of those methods are used in new construction as a quality control test. They can be used to locate an active leak. We call that forensic ELD. The physics are the same. Concrete or metal deck, exposed membrane, electrical path from the top down. And water in that assembly is what's carrying the electrical current. and the farther that water has to travel. And the more electrically insulating layers it needs to flow through, the higher the likelihood that there's a break or a gap in that water coverage or that electrical path. So it might take a couple of forensic ELD tests to be able to find all the breaches. We know water is coming into the building, but we don't know where it's coming from. And we don't know if there are breaches in the membrane. And if there are, how many are there? And is there a water path from the breach through all these layers coming in contact with a concrete deck? So with an active leak, the longer that leak has been present, the higher the likelihood that those breaches can be found. Forensic ELD is all dependent on water being trapped in a continuous path from the surface of the membrane to the surface of a concrete or metal deck. Does not have to be fluid or water, but those insulating materials, if they are damp, that is enough to carry the electrical current. The farther that water has to travel and the more dry insulating layers it needs to flow through, the harder it is to find those breaches in the membrane. Now, if it's mechanically fastened, those fasteners are often electrically grounded, but the test still requires water to make its way through the membrane and touch a fastener. If that doesn't occur, the water has to continue to saturate through and touch something else electrically grounded. If the deck is wood and there's nothing electrically grounded above it, then the chances of finding a breach in that situation would be very, very slim. Now back to new construction. All four methods have to have a conductive substrate directly under the membrane. And on the waterproofing side, that's usually structural concrete. It does need to be water cured or moisture cured. We found that chemically cured concrete might not be sufficiently conductive enough. So we feel it's best that it should be water cured or moisture cured concrete. If the substrate under the membrane is going to be cover board or insulation or wood or lightweight insulating concrete, these four layers are electrically insulating, meaning they cannot carry an electrical charge. And the only way that they can is if they're saturated with water, which is the last thing you want in a brand new roof. And so if a membrane is already installed on any of these four, ELD testing can be performed, but the likelihood of finding a breach would be very, very slim, very, very slim, especially if there's a vapor barrier. Now, if the membrane has not been installed yet, then a conductive medium can be added in. And a conductive medium is just a specially designed product that gets added into a roof assembly directly under the membrane, and that creates that required conductivity for ELD. And that's what our TruGround is. TruGround is just a water-based primer with carbon black. That's what makes it conductive. It comes in a 5-gallon pail, and that pail will cover about 1,250 square feet. So the contractor will mix each pail thoroughly, paint it onto the surface of that substrate. You can't measure it in a mil thickness. You're basically just making sure that the surface of that substrate is black and that you can't see the substrate through the primer. One pail will take about 1 man-hour to install. It'll usually dry in about 30 minutes. Then they will put down their adhesives and primers and then the membrane. And now low voltage or high voltage methods can be used in new construction to pinpoint those breaches. And they can test that membrane for its entire life, as long as it's exposed. The TruGround is UL listed. It is FM approved, and it has been tested and approved by nearly every single membrane manufacturer out there. And that's for fully adhered. You can torch directly to it. You can fasten through it. It has approvals with fluid applied coatings, as well as loosely laid assemblies with overburden, and it will never damage that membrane. The primer is available for purchase directly through Carlisle SynTec. They are a stocking distributor. There is their product code. And if the TruGround is purchased directly through them, it will be included in a full system warranty as long as it's one of their approved FM assemblies. And to date, there is over 10,000 CCM assemblies in FM. And Chris, would you like to tell them about those?
Yeah, so I just, can you go back to the last slide? I just want to talk a little bit about that then too. So yeah, you see the product code listed there, 341838. The pricing is also in the price book. So if you look in the price book, you'll notice that it's in there. We stock TruGround in the Carlisle, Pennsylvania location as well as the Tooele, Utah location, and that's to cover both coasts and everywhere in between. So if you want this added to an order, obviously we can throw it on a truck going to the job site. So that's the advantage of us being able to stock this material instead of drop shipping it on a different shipment. So yeah, next slide then, please. So we have conducted testing several years ago with FM, Factory Mutual, and what we did is we qualified all of our single-ply bareback membranes, each one of those technologies, right? However, we only tested each with one adhesive to kind of the whole family of different cover boards and insulations. So currently, with FM, we have EPDM and TPO bareback membranes adhered using CavGrip 3 to the substrates that we show there. So the coated glass face Secure Shield products, the Detec Prime, and the Secure Rock product. With PVC, at the time, the only adhesive that we tested with FM was the low VOC PVC bonding adhesive, because at the time we didn't have the CavGrip PVC adhesive available. So at the time, this is what we had and this is what we have approved. We have PVC with low VOC PVC bonding adhesive to the paper-faced Insul-based product, as well as the family of Secure Shield products. Right, and so you may ask yourself, well, why do you have Detec with EPDM and TPO and Secure Rock, but not with PVC? And it just comes down to the way that the testing was conducted with FM and what FM requires to give approval. And the way that it works is we know that we have known acceptance through large-scale testing of those membranes and those adhesives to those different substrates. So what they did was they did regular, just small-scale peel tests of controls with those adhesives and membrane combinations. And then they did, you got a kind of a baseline peel strength, and you compared that to the peel strengths of the assemblies with TruGround in them. And FM requires that the peel strength be at or better with TruGround versus the one without TruGround. So I wanted to kind of tell you that because it's not necessarily that we can't adhere to TruGround, but FM only allows these because these are the ones in small scale peel tests that peeled better, as good or better than the controls, right? And that's why every other one here, all the other substrates that we tested, we will still allow for warranty, but they're just not FM approved. And currently we're in the process of getting additional third-party testing. It won't be FM testing, but we're going to have third-party testing for warranty compliance and code compliance with PVC and CavGrip PVC to the whole family of substrate boards, as well as the fleece back membranes with flexible fast. For some reason, I wasn't in charge at the time, but we didn't test fleece back membranes with FM, but we're going to try to achieve those third-party testing for warranty. Because obviously we want to test these before we provide warranties for them. So next slide, Sean, I think that might be back to you, right? Oh, no, so this is still me too. So yeah, we have supporting documents on the website. So that first one there on the left is the ELD cell sheet, the Detec ELD cell sheet. This is the document that lists all of the FM approved assemblies. And then on the back side, it has the ones that we approve for warranty, but that aren't FM approved, right? So it's going to list both of them, the warranty ones as well as the FM. And obviously the FM approved assemblies are also warrantable assemblies from Carlisle. Then we have the TruGround product data sheet, and that's obviously what you're going to use in your submittals if you want to use this particular conductive substrate. It's got everything described and explained in that document. And then one thing that we don't have listed is that we have a TruGround installation video that is live now on the Carlisle website. So if you'd like to see a video of how this material is applied, and you actually will see some video of the IntegraScan testing being done. That video is live now if you'd like to access it.
Thanks, Chris. So the other conductive medium that you might hear about is called, it's called a wire mesh. It might be called a grid. It might be referred to as a grounding screen. It could be aluminum or stainless steel. It's basically just like chicken wire that you would find at a hardware store. It is conductive. The problem is that a lot of membrane manufacturers don't allow it directly under their membrane, so they force it to go below the cover board, which actually invalidates the test. The cover board cannot carry an electrical charge, and the only way that it can is if it's saturated with water at every single breach location, which cannot be confirmed. And so the proper placement of a conductive medium is directly under the membrane. That is per both ASTM standards, D7877 and D8231. If you ever see it in a specification for the wire mesh or for a conductive medium, always make sure that it goes directly below the membrane. Otherwise, it's defeating the purpose and you're really wasting your time and your money. So here is a quick summary of.
Hey, Sean,
yes.
One more thing quick before you get into the summary. I just wanted to, can you go back to the last slide? Yeah. So I just want to address this too. So Carlisle's stance on the conductive substrates. Obviously, we sell and we really are promoting the TruGround conductive primer because we feel and we know that it's the best conductive substrate for use in conventional assemblies. However, if you would like to use this mesh from other suppliers, we allow that in our assemblies as well. However, we only allow it with non-conductive, which is, again, going to be your like thermoplastic membranes, and only for fleece back membranes, right? That's the only way that they will allow it. Fleece back with flexible fast with this grid directly below the membrane and kind of encapsulated within that flexible fast. And even at that, we don't provide any type of warranty for it. We just say that we will allow it, but if for some reason it was to delaminate because of it, that's not included in the warranty. Right, so I just want to be clear about that as well. The only way you're going to get a warranty, including a conductive substrate, is if we use Detec TruGround.
Thanks, Chris. Obviously, if you see a conductive medium, you want the TruGround. That's the way to go. So here's a quick summary. Today we talked about two different categories to ELD. There's the ELD testing of the membrane, and then there's what's called a conductive medium, which our product is called the TruGround. So often terms are mixed matched regarding ELD. Somebody will call it a leak detection system. Sometimes that term is talking about the testing, sometimes it's talking about a conductive medium, and sometimes other people are referring to a monitored system. So you want to keep the terms current and consistent. That is ELD testing of the membrane and a conductive medium, which enables that testing. Usually that's in conventional roofing, TPO, PVC, EPDM, and ModBit. So keep mind of those terms that you use. There's 4 methods of ELD, low voltage and high voltage. They all have the same physics and same basic requirements, and that is conductive substrate, exposed membrane, electrical path from the top down. All 4 of those methods are primarily used in new construction, but they can be used to locate an active leak. We call that forensic ELD. Valid ELD is only on an exposed membrane. You cannot reliably, repeatably, conclusively get an electrical current or a leak locating signal through any type of overburden, especially if there's drain mat, root barrier, and insulation. Don't fall for that lie. And then lastly, the scanning platform is the only method capable of testing a semiconductive membrane, such as black EPDM. And again, a vertical unit will be available next year. As far as conductive mediums go, the most approved option is the TruGround Conductive Primer, which is available directly through Carlisle SynTec. And the purpose of that conductive medium is to make the substrate directly under the membrane conductive. So that is the proper placement of a conductive medium per the industry standards on ELD. And CCM does have over 10,000 FM assemblies with approvals, and they have a competitive advantage over all other membrane manufacturers. And at this time, if you have any questions, please send them in through the chat. And Chris, ask away.
All right, yeah, so we did get several questions that came in, Sean, so I'll just ask them to you, and I'll let you address them unless they're specific to Carlisle. Okay. So the first one is, how much water is required for the scanning platform?
Great question. So the area does not need to be flooded, but again, the physics of ELD needs a water path from the surface of the membrane to the surface of the conductive substrate. So you have to wet the membrane down, and whatever the mill thickness is of that membrane, the water's got to have a path from that surface of the membrane to that surface of the conductive substrate. There is a video on our YouTube channel that specifically addresses this question. Now with this method, as the platform is being pushed along the membrane, it actually will drag water with it. So you can actually see a video, and I think I did put in there, this is exactly how much water you would need for this type of test. Good question.
Good, yeah. So I got another couple on the same basic topic, and I'll kind of combine them. So the first one is, does OSHA have any issue with using the quote unquote human electrode method for pinpointing the leak? And I'll add to that another question that says, have you thought of using a separate manual test pad instead of using the finger? Because they know that it's just 9 volts of electricity, but it may be dangerous, and it's not dangerous to the human body, but it might scare some customers, for doing that. So yeah, take it away.
Great question. So nothing's been discussed with OSHA about using the finger. The equipment comes with a glove as well. And so the glove was designed specifically for, rather than placing your hand on the equipment and passing the current through your body, you can actually go from the electronics with the cable to this glove, and that has a rubber glove on the inside that is insulating the technician from that cotton glove. So in answer to your question, the equipment does come with an option for the technician to not pass the current through their body. Good question. Nothing has been done with OSHA regarding it. It's just 9 volts. You don't feel anything passing through your body.
Okay, yeah, good. I knew you were going to mention that glove, so that was good.
There's also a video on the YouTube channel. If you'd like to look at that, there's a demonstration of the glove.
Okay, so the next question is, and this one's kind of easy to address, but do you have a company that you can recommend for facilitating the testing in the Ohio area?
Absolutely, that's a fantastic question. So in the Ohio area, there are multiple testing agencies that are Detec certified that would mobilize to the out to that area, and then there's others that are physically there. So my suggestion would be is reach out directly to Detec Systems, and then what we'll do is we'll tell you who those Detec certified testers are, or you can contract directly through Detec Systems, and we would use that local company to test on our behalf.
Yeah, Sean, and that's a good point. Before I get to the next question, I just want to mention too. So Carlisle, obviously, for a warranted system, and if you want an FM approved assembly, we would want to use TruGround. That's really, we're promoting the TruGround. Now, when it comes to the ELD testing itself, any of those 4 approved, ASTM, testing methods are approved by Carlisle. We have no say in how that membrane is actually tested. Obviously, we prefer Detec's low voltage scanning platform, but that does not dictate any type of warranty, right? So that does not, we have no say in that. So just want to be clear about that as well. So although you would buy the TruGround from Carlisle for the assembly, the testing is done by a third-party agency. Now, you can reach out to me if you have any questions, and I can put you in touch with Sean to figure out who the local testing agencies may be. And in fact, last week we hosted a consultant training on the Integra scanning equipment here in Carlisle, and we certified about 20 new 20 new testing agencies. So that's a plan for future as well. We're going to continue to educate the consultant community to conduct this testing. And our SRWA program actually purchased the testing equipment from Detec, and we actually are now providing it through loan, through the SRWA loaner program. So again, we're just trying to help kind of push this industry forward because we really believe in it. So that was a good question. So the next question here, let's see here. Have you, okay, will the primer work applied to polyiso, or do you need a cover board? All right, so we addressed that, right? It'll work to pretty much any substrate that you want to put it on. It'll work to wood, paper face polyiso, coated glass. It'll work on Detec and secure rock. So yes.
Yeah, whatever substrate directly under the membrane is going to be non-conductive, that's where it would go.
Yep. The next question is, this is a good question too. Can the conductive primer be spray applied in lieu of roller applied?
Absolutely, yeah. So most companies that have applied the TruGround, they prefer the roller application method. There has been a couple of contractors that have spray applied it. I believe you would use just a hydraulic sprayer. You're going to have to take out the filter so it doesn't get clogged with the carbon black. But that's as far as I know as far as the application using a spray method. But yes, it can be done.
Okay, good. So the next question then is, are mechanically fastened roofing systems possible through our warranty if you use TruGround? And so that's more for me, Sean. And so what I would say is, yes, they are. So the reason why we tested the adhered systems is obviously because we wanted to see if there was any interaction between the adhesion of that roofing membrane through the TruGround. But if you were mechanically fastening the roofing system, we would have no problem with that. It's not gonna cause any type of detrimental effect. Now, I think there's another question on here about maybe there's not. I thought there was about a Rhino bond system. I think I saw that come through. That might have been from the earlier presentation, but yeah. So will it work with Rhino bond is a question. And I believe the answer would be yes, it would. However, you want to apply the TruGround before you put your Rhino bond plates down. I don't think you'd want to paint over that. But Sean, do you have experience with that?
Well, I know that there is an approval with the Rhino OMG Rhino bond. Preferably, I think it would go on. I mean, it goes on either before or after the plates. I mean, if the plates are metallic and they're touching the primer, then they're grounded as well. So either way.
Yeah, well, but the Rhino bond works through the special plates that have an adhesive kind of built in that is activated through heat. And I'm just worried that, so I guess to answer this question, I think what I would say is, I think you would want to apply the TruGround prior to using your Rhino bond plates.
Right.
Just to ensure that it's going to work. But that's a good idea. We may test that here in the future, just to see if there's any interaction. But as long as it's down before the plate is installed, you won't have any issue. So the next one, so what is the shelf life of the primer?
Yeah, it's a great question. So the primer remains conductive forever. It's carbon black. It is water-based, so it does thicken over time. It has a 1-year shelf life from delivery. It could still be used after that fact, but it does need to have some type of shelf life on it. The longer it's sat, the thicker it'll get. You just need to mix it up a little bit better when you go to apply it.
Okay, good. So another one is in the future, will we be supplying TruGround to the European market? That's something that's definitely a possibility, but at this point, I don't believe there's any plan in place currently. But assuming that TruGround really starts to take off, which it already has, that's definitely a possibility. Let's see. Does the TruGround work with liquid applied roof covers such as coatings or spray polyurethane foam systems?
Yes, it does work with coatings. It has approvals with CCW, all the other fluid applied manufacturers, Hydrotec, Setco, Kemper, GCP. So all the fluid applied manufacturers have been sent samples of the primer and they have tested internally, and provide approval letters. Absolutely.
Okay.
CIM.
Yeah. Yeah, so the next question, we got a couple of these about becoming a certified testing agency.
Mm-hmm. Yeah, so to be a certified testing agency, you have to be physically trained by Detec Systems. There's a couple of ways we could do that. Either they can visit us here at our facility in Washington State, or we could mobilize to one of your live projects and train you on one of those projects, or we will have a training opportunity at Carlisle probably sometime in the spring, where a limited amount of people can come and get trained directly by Detec Systems, and that'll open up the opportunity for borrowing the equipment directly from Carlisle, or purchasing the equipment directly from Detec and being a Detec certified tester.
Yeah, that's a good point. We are planning an additional training here in the spring like I said, like I mentioned, we did a testing or a certification program last week and went really well, and we're hoping to do more in the future. So I think we have a couple more maybe. Somebody asked, will the Detec Integra scanner create enough pressure on the membrane when there's a small wrinkle in the membrane to be able to work? I guess is kind of where that's going.
Yeah, that's a really good question. I mean, the equipment itself is not very heavy, and it's not designed to, push the membrane down at all. So in that case, I would say that the physics apply where it needs a water path from the top down. If there happens to be a breach in that wrinkle, and there's an air gap in between there, it's possibly that the water path could be broken.
Okay, and I think we got a couple more here. So I had one question that came in that said approval letter from Henry regarding their coatings. That's a good point. With the Henry acquisition, we're going to have to work with them for additional approvals. Currently, we don't have anything with them set up, but in the future, I definitely can see that happening. Currently, we don't. Mm-hmm. Another question was, what does the equipment cost?
Yeah, so the equipment is usually sold as a package. It includes both the platform and the roller, all of its accessories and the case that it comes in, and that sells for $13,900 plus shipping, and then training is separate.
Okay, and the last question that came in here, Sean, to wrap it up, feel free to ask more questions. I just see the last one that came in.
Yeah, I'll stay as long as you guys need.
Yeah, can you explain how ELD works with a mechanically fastened system? Wouldn't the screws cause a constant ground from the membrane to the substrate?
Good question. So again, the physics of ELD is the equipment will only alarm if there is a void in the surface of the membrane that allows that path to travel to the fastener. So in low voltage at least, in a mechanically fastened situation, the water would have to saturate through the breach and touch that fastener, which cannot be confirmed. So let's say you test the area, no breaches are found. It doesn't mean that there's no breaches present. It could mean that the water has not saturated through to a fastener. So that's an invalid ELD test. It would still need a conductive medium in that situation. I have heard that sometimes high voltage can spark at the location of metallic plates or fasteners under the membrane, but that doesn't indicate it's a breach. It's just sparking through that thin membrane.
Yeah, I agree there, Sean. And I think maybe more of the question is just, do the fasteners affect the testing? And no, because that's what you're looking for. You're looking for that grounded connection.
Right.
And that's how it works.
Yeah, ELD is focused on the surface of the membrane, not what's below it. And the equipment will only alarm if there's that path from the top down. So no false positives.
All right, actually, I did get another one that came in here, Sean. So, and I think I can take this one. It says, can the TruGround be factory applied to the cover board instead of field applied, and then connect the sheets together in the field? Yes, that absolutely can be done. And I know Sean has mentioned contractors who will maybe, like let's say if it's a day that might be rainy, they'll have their guys apply it in their factory, and then when they get to the roof, they can just lay those boards out. if the question is there a plan to develop a board with TruGround already on, I would say stay tuned. Maybe, I don't know. That's how I would say that. So. All right, well, here, we got another one too, Sean. So with green roofs, what if the green is installed in planters directly over the membrane, or is there no or if there is no insulation installed over the membrane?
Again, same physics. So again, let's say vegetation is installed directly on the surface of the membrane. Okay, vegetation is installed directly on the membrane. Let's say there's no drain mat, root barrier, insulation in between those layers. Then the tips of the probes can contact that physical membrane. Okay, but again, that wire would have to be left in place after the initial test, and that overburden has to be saturated with water. So within those limitations, it might work. But again, if there's insulating layers between the surface of the overburden and the membrane, that's where the break in your circuit will happen, and the leak locating path is disrupted.
Okay, good. And then we got another one. Can TruGround primer be applied to ISO boards, or does it require a cover board? So we've addressed this earlier, I think, but it can be applied to the insulation as long as the insulation. So we've approved it with all of the standard insulation. So InsulBase, Secure Shield products, whether it be the Secure Shield HD, Secure Shield HD Plus, or regular Secure Shield, as well as Detec Prime and Secure Rock. So yeah, it can be insulation or a cover board. However, if it needs to be FM approved, only some of those are approved with FM for reasons I explained earlier. So
yeah, and it's got to go directly below the membrane, whatever that substrate.
Exactly, true.
Whether it's cover board or insulation. Now, let's say for some reason it's not allowed on the cover board and it has to go on the surface of the insulation below that. That can happen, but again, that test now does not comply with the ASTM standards. It would not be our preference to place the TruGround on in that assembly at that far below the membrane. So in that case, it could be used, but the results of the test would be considered invalid.
All right, Sean, thank you. That's the last question that came in. I really appreciate all the questions that came in. This was really great. If you have any additional questions, feel free to send me an email or give me a call. But for now, I think we're going to sign off, and I just want to thank Sean again for the time, and we look forward to working with all of you here in the future.
Great. Thanks, everybody. Have a wonderful day.